Hello and welcome to Cartographica's website, macgis.com. In this quick tour, I'll be highlighting the new cluster analysis functions in Cartographica version 1.4. Cluster analysis involves choosing and setting a number of parameters that are used to identify hotspot locations of point-level data. Clusters are areas that have high concentrations of a particular incident. Knowing where high concentrations of certain things are located can be a very valuable tool to analysts conducting spatial analysis. In this example, I'll be using data from DCGIS. The two layers on screen are a census tract layer and a burglary layer. To perform cluster analysis, go to the Tools menu at the top and click Find Clusters. Here is the cluster analysis window. Our cluster analysis methods are similar to methods found in the crime analysis software CrimeStat by Ned Levine. For a good source of documentation on these methods, check out Ned Levine's CrimeStat website. The two main parameters used to identify clusters are minimum count and distance, which you see here and here. First, I'll talk about the minimum count parameter. Minimum count allows you to determine how many points are needed to identify a cluster. For example, if the minimum count is set to 5, then no cluster that is identified will have fewer than 5 points. The distance parameter is used to determine a search distance between points to identify nearby neighbors that are parts of clusters. Only points that meet these criteria will be used in the cluster analysis. The distance parameter has several options available, the three you see here. First, the fixed distance method will only identify point clusters that fit the minimum count criteria and are within a specified fixed distance to other points. The one issue with the fixed distance method is that the distance is arbitrary and up to the user to decide, so you need to have a good reason for selecting a specific fixed distance. The average nearest neighbor method, which is in the middle, identifies point clusters that meet the minimum count criteria and that have an average distance between neighbors that is greater than a threshold distance. The threshold distance is based on a k-order distance distribution, where k is the number of nearest neighbors used to construct the distance distribution. A higher k-order will result in a distance distribution that has a higher average. The higher average will result in an output with a larger hotspot area. The expected mean distance method, which you see here, identifies points that fit the minimum count criteria and are within a randomly defined threshold distance. The confidence interval is used to set a probability that any pair of 2 points would be within the threshold distance. A confidence interval of 50% means that 50% of point pairs will not be within the threshold distance if the distribution of points is spatially random. The confidence levels are specified by using the slide bar, which you see here. Moving the slide bar all the way to the left corresponds to a confidence interval of 99.99999%. The fourth position here corresponds to a 99% confidence level. The fifth position, a 95% confidence level, and the sixth position, a 90% confidence level. So some of the more common confidence intervals you'll see. On the far right corresponds to a 0.001% confidence level. The result of selecting the various confidence levels is that the larger the confidence interval, the smaller the resulting cluster area will be. So the confidence level on the far left will result in the smallest cluster area, and the confidence level on the far right will result in the largest cluster area. Down below, the average distance value tells you the average distance between pairs of points. So if you can imagine a distance distribution, the value that you see here, 46.96, would be at the center of that distribution. Below, the NNI value is the nearest neighbor index, which indicates whether or not there is clustering in the data set. The index compares the average distance from the closest neighbor to each point with a distance that would be expected based on chance. If the average distance is the same as what would be expected based on chance, then the nearest neighbor index would equal 1, indicating no spatial clustering. If the average distance is smaller than the expected distance, then the nearest neighbor index will be less than 1, indicating clustering in the data, which is the situation we have here. If the average distance is greater than the expected distance, the index will be greater than 1, indicating that the points are more widely dispersed than what would be expected based on random chance. To illustrate how cluster analysis works in Cartographica version 1.4, we can show an example using the burglary data. So we'll perform a cluster analysis using the expected mean distance method. And first we'll set the confidence interval to the highest level at 99.9999%. And we'll click Find. You can see a burglary hotspot layer that's been created and added to the layer stack. I'm going to click on the burglary layer again, and then click on Tools and Find Clusters. Choose the expected mean distance method, and this time slide the slider bar all the way to the right, and click Find. What we'll expect to find here is that the more recently created hotspot layer will have a broader area. So we can uncheck the burglary layer and move our two layers to the top of the layer stack. I'll change the color of the hotspot layer on top to something other than white. So the layer that's been colored salmon is the layer, the hotspot layer that was created with the 99.9999% confidence level. And you can see that the area for those hotspots are smaller than the area created with the smaller smaller confidence level, the 0.001% confidence level. That's cluster analysis in Cartographica version 1.4. Thank you for listening.